Hey Math 1, this is the video for section 1.4. It's sort of the third take on number comparison. All I did was I added one more number in the mix, so let's get to it. So I'm giving you guys four different negative values here in which you have to order, either from least to greatest with less than symbols or greatest to least with greater than symbols. So since you got one that's a decimal and three fractions, the idea is we want a common language between all four numbers. And decimal seems to make the most sense. Now, the interesting thing that I've seen over time is that whenever I give students this particular example, they tend to be so laser beam focused on the square roots, turning things into square roots, that they just start multiplying 39 over 7 times itself, and 34 over 33 times itself, and 29 over 5 times itself, and 6.03 times itself. Again, that's turning them into a number language that isn't even in the original one, right? So it's kind of like, this person speaks English, 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 French. Let's convert everything into German. Makes no sense. Why would we do that? So let's just find the decimals for all of them. So 39 divided by 7. At this point, we should be thinking these are kind of more basic examples. It goes in there 5 times. Drop it down. 7 times 6 is 42, so it's going to be 5 times again. And at this point, we could keep getting digits of accuracy, but let's just hold off on that because we can instantly already compare negative 5.5 to negative 6.03. Let's move on to the next one. You know what? I don't even think we need to make this into a decimal just yet. Here's why. 34 over 33 is the mixed number 1 and 1 over 33. I mean, I'm just looking at this and thinking, there's no way it's going to be negative. Like, negative 5 is way smaller than negative 1, as is negative 6. This one right here, we don't need to figure out the decimal for it. You can just leave it as is. All right, negative 29 over 5. I'm not going to scroll down. It would kind of mess up the whole sequence we got going here. Negative 29 over 5. Let's first check to see what kind of mixed number it is, because that seemed helpful over here. Let's see, 5, 10, 15, 20, 25. It goes in there 5 whole times. Well, we got this one, so we should probably keep going with that. There's 4 left over, so it's going to be in 4/5. If you remember, we did 4/5 already as a decimal from a fraction, and 4/5 is 0.8. So I'm hoping you guys are building a bank of commonly used fractions where you can go back and forth between decimals and fractions pretty much with total ease. All right, so I think we got it. Who's the smallest? Negative 6.03. The one smaller between these two is going to be negative 5.8. Negative 5.8 is further left on the number line than negative 5.5. So we're going to go to the original of that, negative 29/5, which is less than this one, which is negative 39 over 7. And that's less than this negative 1 point. I think that's 0.03 repeating value. And there's a comparison sequence. Again, I want to emphasize the fact that we didn't multiply any of these values times themselves because there were no square roots that we had to compare them with. So. Number 2, we've got root 7 in this box, 51 over 19 in this box, negative root 14 in this one, and negative 3.74 in that box. So it seems like it would be to our advantage to actually move these non-square root values to compare to their square root counterparts. Now, we got a double thing going on here where these two negatives are the ones in question. They're going to be the smaller of the two numbers because negative numbers cannot be bigger than positive numbers. And yeah, so let that kind of guide our work. 3.74 multiplied by itself will convert it into an easy square root. So let's do that work. Our first row of calculation should be 4 times 4 is 16. Carry a 1. 4 times 7 is 28, plus 1 is 29. Carry a 2. 4 times 3 is 12, plus 2, 14. There's your first row. Second row, make sure we started off with an extra digit of accuracy. That 4 is gone with a 0. 7 times 4 is 28. Carry a 2. 49 plus 2 is 51. Carry a 5. 7 times 3 is 21 plus 5 is 26. Check out your second row of calculations. All right, and then the third row, you've got double 0, followed by 3 times 4 is 12. Carry a 1. 3 times 7 is 21, plus 1, 22. Carry another 2, and then you got 9. 3 times 3 is 9, plus 2 is 11. So check out your third row. Add them all up. Get 6, 17, carry a 1, 5, 6, 8. And then 6 plus 1 is 7, 9, 3, 1. Keep in mind that the digits of accuracy, you're going to move 1, 2, 3, 4 places in if you had 1, 2, 3, 4 digits to the right of the decimal point. And that's good information because now negative root 13.9876. You know that those two values are going to be the smallest in the comparison sequence. So right away, in my comparison sequence down here, negative root 14 is the leftmost number on the number line. It's less than our negative 3.74, which will be less than whichever of these numbers turns out to be smaller. So let's get to that. Now, 51 over 19 is, let's see, that goes in there 19, 38, 57. So it only goes in there twice. And there seems to be 13 leftovers. So if I had to estimate, that'd be like 12.6 to 7-ish. Or, I'm sorry, 2.6 or 7-ish. In 7, 7's right smack dab in between root 4 and root 9. Seems to be closer to 9, which kind of, I guess it verifies the fact that these two numbers are going to be too close to just straight up guess which one's bigger. So we got to multiply it by itself. 51 over 19 times 51 over 19. All right, so 51 times 51, we can do the work off to the side. I'm guessing it's 2,601. These are your two rows of computation. All right. Score 2,601 is our numerator. Our denominator, again, we can do the work off to the side, but if you've got 19 squared memorized, you can just go right for it. So 361 is 19 squared. Now, if you run out of room in this box, it's okay to do some work in the box that you're comparing it with if there's nothing else that needs to happen over here. So the 2,601 divided by 361 calculation seems to be a good candidate to go in that box. So 361 goes into 260 0 times. So you're basically just guessing and checking the whole thing. Does it go in there 6 times? Does it go in there 7 times? Does it go in there 8 times? You know what? I'm just going to take a guess. Let's just go with 7. So 7 times 1, 7 times 6, 42, carry a 4. 7 times 3, 21, plus 4 is 25. And that instantly tells us that it's going to be, this value is a number that's bigger than 7 when you multiply it by itself. So 51 over 19, I don't really even need to do any more work with this. I can just say it's 7 point something versus 7 point nothing for the root 7. Sorry. 7 point something is more than 7 point nothing. So, this is kind of a caveman way of going about talking about it, but I believe he gets the job done. 51 over 19 is the largest number. Root 7 is the smaller of the two positive numbers. All right, I hope you found this video helpful, and yeah, good luck with it. We'll move on to a different topic on our next video. So, see you then.